Hello students, in the previous class we have seen the basics of chemical kinetics. In that case we have defined the chemical kinetics, and the definitions of chemical kinetics is that the chemical kinetics is the branch of physical chemistry which deals with the study of rates of chemical reactions and factors which affecting the rate. Okay, and at the end of lectures we have seen the definitions of molecularity, and for understanding the molecularity of the reactions we have discussed the how to calculate the molecular, how to calculate theoretically molecularity of the reactions, and in that case we have seen the unimolecular reactions, bimolecular reactions, trimolecular reaction, etc, etc. Okay, dear students, today I am going to discuss the new topic of our syllabus, that is order of reactions. So this is our new topic from your syllabus, or you have already seen these definitions of order in your T.Y.B.Sc class, but still I am writing the definitions of these reactions and what do you mean by order and how to calculate or how to determine the order of any chemical reactions. This is your syllabus. Okay, so order of any chemical reactions can be denoted by small n. This is small n. If suppose in chemical kinetics small n is given in any books or any reference books, and you have seen this n. So n means what? Order of reactions. In the chemical kinetics, the order of reactions can be denoted by small en. So the definitions of order is that the sum of all exponents sum of all exponents to which the concentration terms, to which the concentrations in the rate equations are raised, and this is called or is known as order of reactions. Order of reactions. This is the definitions of order. And for better understanding this order, you must know the what do you mean by first order reactions, what do you mean by, because in our syllabus is third order reactions and zero order reactions, or third order reactions we have to see. Before going to discuss these third order integrated rate equations, we have to know the order concept order. And for the better understanding, we can for the better understanding for the this order, we can define we can consider the general chemical reactions as the reactant gives product B. For these reactions, I can write the rate is equal to K into concentrations of 1. Here is exponent 1. This rate law comes from the law of mass action. Law of mass action is that what? Rate of any chemical reactions is directly proportional to the concentrations of reactants. This is the law of mass action, and this rate law comes from the law of mass action. If you have to law of mass actions, if you have to go into detail of this law of mass actions, then you have to see your second year B.Sc books or second year notebook, or if your notebook have, then you can see the law of mass actions. So the law of mass action is that the rate of chemical reaction, R is the rate of chemical reaction. Rate of chemical reactions is directly proportional to the concentrations of reactant molecules On that basis, on the basis of law of mass action, I can write the rate law. This is your rate law. So the rate law is equal to this is your rate constant K into concentrations of A molecule, that is reactant molecule. And for these reactions, I can write this reaction is first order reaction. This reaction is first order reaction because only one concentration term involved in the rate equation. That's why I can write this reaction. This in general reaction is first order reaction. If suppose I can write same reactions like that, this product C, A and B are the reactants, gives product C, and for these reactions I can write the rate equations like that. Rate is equal to K into concentrations of A into concentrations of B, because two reactant molecules are involved in the rate equations. Here is one exponents, and in the definitions we have right here the sum of all exponents. That means two concentration terms involved in the rate equation. That's why I can say this order of this reaction is 2. That's why I can say this reaction is second order reaction. This reaction is second order reactions. Okay, so like that reactions, again I can write same reactions like that. Gives product B. 2 moles of A reactant gives product B. If suppose the rate equations for these reactions I can write like that. Concentrations of A, exponents is 2. So I can say this reaction is second order reaction. I can say this reaction is also second order reaction. Okay, so this is another type of second order reactions. So here is also third order reactions. A plus B plus C gives product D. I can write for these reactions rate is equal to K, concentrations of A, concentrations of B, concentrations of C. This is rate equations for the these reactions, and I can say this is third order reaction. This reactions is third order reactions. Third order reactions I can write like that also. 2 moles of A product gives product B plus B gives product C. The rate equation for these reactions I can write like that. A 2 moles and B 1 moles, and so the order of reaction is third order reaction. Third order reactions. So on the definitions we can identify from the rate equations the chemical reactions order. Order of any chemical reactions can be identified from the rate equation. This is experimental property. Order, you cannot define this order is first or second by theoretically. This is experimental conditions. You have to if suppose A is the reactant with product B, so the rate equation is like that. I am right here theoretically, and this is general chemical reactions. That's why I am writing here the rate equations for this reaction, and I have said this is first order reactions. But if you have to check, you have to perform this experiment in laboratory. You have to perform experiment on these chemical reactions in laboratory. You have to perform the experiment. On that basis, this rate law is changed or not, you have to check. And so this order of reactions is experimental property. You can check by experimental, or you can determine from the experimental data. Okay, so this is the definitions of order of reactions, and you can say this is first order, this is second order, this is the second order, this is third order, this is the third order reactions. Okay, so likewise some first order chemical reactions and some second order chemical reactions, some third order reactions, chemicals. Examples of this order, you have to know some examples, and I am writing here the examples of this order reactions. Two molecules NO, nitrogen monoxide, just a minute, nitrogen monoxide reacts with one molecules of oxygen. It gives product two molecules of NO2, two molecules of NO2. That means nitrogen monoxide is reacting with oxygen molecules. It gives two moles of nitrogen dioxide. That means the order of this reaction is, so write down first the rate equations for this reaction is rate is equal to K into concentrations of NO, nitrogen monoxide, exponent is 2 into concentrations of 1 into concentrations of 1. So I can say this order of this reaction is 3, that is N is equal to 3. That means this is the third order, this is the third order reactions. Likewise, we have seen the number of chemical reactions in your daily life or in your in our chemistry. So the order of that reactions we can calculate or we can determine from the experimental data. Okay, so this is the third order reaction, example of this third order reactions. So I hope all of this this concept order of any chemical reactions can be denoted by N, and all these things you have to understand, and if you don't understand then you can ask me. Okay, so this is the basics of this order is the basic for and this order is not the definitions of order is not important for your exam point of view, but you have to know the uh, definitions and what do you mean by this order and molecularity, because in your SY.B.Sc you have already seen, but some basic concept if as we know the chemistry is a volatile subject and you have forget, you have don't remind if you don't remind it the what do you mean by order and what do you mean by molecularity, what do you mean by chemical kinetics, what do you mean by rate, all that things I have covered in previous lecture and in this lecture, order, molecularity, rate of chemical reactions and chemical kinetics and all that things. So one is the most important, the difference between the order and molecularity you must have to know. This is molecularity. In the previous lectures, molecularity of reaction, we have discussed the molecularity of the reactions. So the difference between, what do you mean by difference between order and molecularity, or suppose the questions may ask like give the difference between the order and molecularity. If in your SY.B.Sc you have already this questions or prepared for this molecularity or difference between your molecularity and order of reaction. So in T.Y.B.Sc you have to know the what is the difference between order and molecularity, because order and molecularity is not same thing. So we have to know the difference between the order and molecularity. This is your order of reactions, order of reactions. Okay, so first its difference is that you have to mention the definitions of molecularity, and in the definitions we have said the molecularity is the number of reacting species, number of reacting species involved in the chemical reactions. This is the molecularity. Chemical reactions is known as molecularity of reaction. Molecularity of reaction. Molecularity of reaction is that the number of reacting species, how many reacting species involved in the chemical reaction, or this is called the molecularity of reaction. If suppose one molecule is involved in the chemical reactions, then we can say this molecularity of this reaction is 1 and this reaction is two molecules is involved in the chemical reactions, then we can say the molecularity of this reaction is 2 and this is biomolecular reactions. So this is the first difference. Number of reacting species involved in the chemical reactions is known as the molecularity. So here I have write the definitions of order, and in the definitions we have just see the definitions of order of molecular order of reaction is definition is that sum of all the exponents all the exponents to which the concentrations to which the concentrations in the rate equations are rates are called order of reactions. This is the definitions of order. So this is the definitions of molecularity, this is the definitions of order. Second difference is that molecularity is a theoretical property. If suppose any chemical reactions is shown in your notebook or in your book or any reference books, you can say suppose chemical reactions like that A plus B plus C gives product B. You can theoretically say these chemical reactions also the molecularity of this reaction is 3. Molecularity of this reaction is 3. That's why we can say this reaction is trimolecular reaction. If suppose any chemical reactions like that written like that A plus B gives product C, then the molecularity of this reaction is 2 and we can say this reaction is biomolecular. So this is your experimental property. This molecularity is your theoretical property. Theoretically you can say. So this is molecularity is a theoretical property. It is a theoretical property. And for the order, if suppose any chemical reactions and you have to determine the order in your laboratory. You have to determine if suppose chemical reaction is you have to perform if suppose chemical kinetic study of any chemical reactions, and I know because you have studied in the T.Y.B.Sc practical exam the chemical kinetic study. If suppose you have reminded, then no problem, but if don't remind, then you have to see your T.Y.B.Sc practical books. Okay, so this is your it is a experimental. It is a experimental property. This is experimental property. This is experimental property. Order of any chemical reactions, you cannot say the order is this reaction so and so reaction is first or second or zero or any other number. So you have to perform first experiment on that reactions, and after that you have to determine the order of reactions, and after that you can say this reaction is first order, this reaction is second order reaction, this reaction is third order reaction, etc. Okay, so this is the theoretical property, this is experimental property. Next difference is that it cannot change. This molecularity cannot change by experimental conditions or with experimental conditions. With experimental, I am writing here experimental conditions. Because why molecularity does not change? If suppose I am changing temperature, molecularity is not change. If I am changing pressure of chemical reaction, molecularity does not change. If I am changing concentrations of the reactant, molecularity is same. So molecularity cannot change with experimental conditions. whatever the experiment conditions you have to maintain in your laboratory, but molecularity is same. Molecularity does not change. So we can say it cannot be changed with experimental condition, and this is theoretical property. That's why on the experimental conditions, this molecularity is not depend. Molecularity is not depend on the experimental condition. So if temperature is changed, temperature is increase or decrease, molecularity is same. Pressure increase or decrease, molecularity also same. Molecularity does not change. That's why this molecularity is not changed with the experimental conditions. Similar way, this experimental property, order is experimental property, so it depends on the experimental condition. If suppose I am changing concentrations of reactant, then the order of reactions can be changed. So third difference is that it change with experimental conditions. With experimental conditions. If I am changing temperature, the order of reactions will change. Experimental condition, it changes with experimental conditions like temperature, pressure, or concentrations. Concentrations of a reactant. If I am changing concentrations of reactant also, order of molecularity is also changed. Just a minute. Okay, so this is the difference between this molecularity and order of reactions. Last difference of molecularity and order is that molecularity cannot cannot be zero or fractions. Molecularity cannot be zero. Molecularity cannot be zero because molecularity is theoretical property. If suppose I am writing here the chemical reaction A plus B gives product D. Like that is another chemical reactions. Number of chemical reactions you have to observe in your notebook or in your book. But you don't have observed like that. No reactant molecule is here, and simply you get product of any chemical reactions. You have not observed such type of reaction, and that's why we cannot say we can say the molecularity of any chemical reactions cannot be zero or fractions. Fractions means what? 3s22, 1s22, 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 3s22, 4s22, like that. Fractions value of molecularity is not possible. Fraction value of any reactant molecule is not possible. So we can say the molecularity cannot be zero or in the fractions value. Okay, so in these definitions you have to write exactly opposite to this value. Order of reactions. Order of reactions can be zero or fractions. Order of any chemical reactions can be zero or maybe in fractions. Okay, so this is experimental property. This is very important sentence you have to remind in case of order. The experimental property. So experimental property means what? This experimental conditions, if suppose you have changed, like temperature you have to increase. If suppose temperature increase, then the rate of reactions also increases. Rate of reaction increase means what? Rate equations may change. Means what? Order of reactions is also change. So order of reactions can be zero or in the fractions. The order of reactions can be zero or fractions. This is the fourth difference between the molecularity and order of reactions. Last three difference, suppose I can write like this: from the molecularity, from molecularity, from molecularity, no idea, no idea about the rate is about the rate of reaction, about the rate of reaction. From the molecularity, we cannot understand or we cannot determine what is the rate of reactions, or no idea about the rate of reaction. What is the rate of reactions? We can from the molecularity we cannot we don't have any idea about the rate of reaction. So this is the last difference between the molecularity and order. You have to do this. You have to write the exactly opposite sentence to this. What is the definition? What is the sentence? From the order. From the order. From the order.